Okay, I'm going to speak about Singularity. Hopefully you all are kind of familiar with it. So first I'm going to introduce myself a little. I'm Eduardo Arango, come from Cali, Colombia, for those who know Colombia. I'm a software engineer at Sylabs, the startup that was born after the Singularity open source project. So this is a new company started this year that is relying on Singularity that has almost 3 years now in the field as an open source project. And my responsibilities are about taking the Open Container Initiative kind of certification into the Singularity runtime. And also, I'm part of the group that are migrating all the code base of Singularity into Go. So part of the Singularity runtime is in Python and Bash, and the core runtime is in C, but we are moving all the Python and Bash into Go, so I'm part of that group. So I'm going to do a small introduction to containers. So is everyone here familiar with containers, or is this a new topic for part of the HPC community? So I'm going to start from scratch for why Singularity and why containers in HPC. So the ideal scenario in HPC or in any HPC infrastructure is a single user that wants to use the same software stack for his whole life, and anything is going to change. But this is what we are having right now in any HPC infrastructure, or not HPC, but research computational infrastructure. Many users, and those many users want to use different software stacks and in different versions. So we are having a really bad time trying to have all these users happy using their different software stack in the same infrastructure. So this is really what Singularity was born, trying to attack this issue, and the users itself and the open source community were in charge of making this project bigger. So containers 101. Containers are an encapsulation of the operating system. So we are leveraging the namespaces features of the kernel to mount a different file system at runtime. So when a process is about to run, what Singularity do, or any container runtime is doing, is making a system call to the kernel to change your operating system in runtime. So the binary that you are going to use, your software stack, a moment before going into the process pool, is going to read a different file system, a different environment, and by doing that, it's going to jump into that process pool with a different environment than the host. So what is this solving? So we can have a Route 7, a Route 6 infrastructure, but being running CentOS, Ubuntu, Linux Mint, Alpine containers in the same infrastructure. So this will help users that they can develop in their laptops, in their workstation, in different environments, and go into this monolithic infrastructure that has a really stable file system, and the system admin doesn't have to change the file system of the infrastructure. The users are going to take their environment into the cluster and just run their tasks. So they are easy to share, easy to distribute, and validate and reproduce. There are multiple implementations of containers. Obviously, there is Docker. There is LXC from Canonical. There is the CoreOS Rocket. But all the container runtimes out there in the market are mostly for services. Singularity is born because, as I speak with some people, users started to use Docker in their workstation and started to request to the system admins to install Docker in the HPC infrastructure. But this is impossible because all these container runtimes, they require root access. So you know, HPC system admin won't give root access to users. So Singularity is born there, being able to use the concept of containers, being able to use the namespaces of the kernel, but without root access. So for those that doesn't know what a container is, when someone that is new to containers, they just say that it's a lightweight virtual machine. So this is why this slide is so important. So it's kind of a virtual machine in the case that you are containing all the file system and your application. So you have a different operating system and you have your application contained in a file that you can call a tar file. You can call it a zip file. But we are not virtualizing the hardware. We are using the same host kernel. So in the container, you are going to swap the file system, but you are sharing the same kernel. So this is important to know. The kernel that you have installed in your infrastructure is going to be the same kernel inside the container. You are just swapping the file system at runtime. So this is the main difference. You are not virtualizing the hardware, you are sharing the same host kernel, and by sharing the host kernel, you are leveraging a lot of things, because when using a container, as you are seeing the same kernel as the host, you can use the same hardware as the host. So you can use GPUs from a Singularity container without installing anything. So if the file system, if your application needs to use a GPU or needs to use a specialized hardware, let's say InfiniBand or I don't know, anything that you need to use, it is going to be able to use it without any special setup that you have to do in a virtual machine, because, well, using hardware from a virtual machine requires some setup. So what makes Singularity different from the rest of the container runtimes out there? So, as I was telling you, Singularity was built especially for HPC resources, now going into science and now going into enterprise, because enterprise and HPC share that is not giving users root access. It's another thing that is special for us, and a lot of people are like this. It's a single base file, because Docker and all the other runtimes, they use layered file systems. This is good for software development, this is good for services, this is good for a lot of things, but not for science and not for HPC. Because for HPC, this goes against performance. And for reproducibility, having different layers is good for enhancing the storage when you are doing software development, but not in science, because in science you need to ensure reproducibility. So a single base format is better for that. So this single base format is extreme for mobility. You can ship your container as a tar file in a USB, in an email, stored in Dropbox, in Google Drive, and anything that you can store a file, a binary, you can store a Singularity container. Cross-compiling compatible, I've been talking with a lot of people about, you can store in a single container different architecture for your same binary. So this is quite good now that we are seeing in a single company different infrastructures, because everything is changing so fast, and in 2 years we're going to have x86 with ARM architectures in the same company. So we need to have cross-compiling and ensure that for the users, because as I can use my computer right now, they say that laptops in 2 years are going to come with ARM chips, not with Intel chips. So people are going to be developing in ARM and shipping software to an infrastructure that may be still in x86. So we need to ensure users that this cross-compiling and that they can ship their binary, and that binary is going to run in the infrastructure. And lastly, and not less important, the security model. As we are preventing users to have root access from Singularity, we are also blocking some system codes that may be dangerous from an HPC or from an enterprise point of view. So when the user is running a process inside a Singularity container, we are blocking the system calls that it can do. So I'm going to speak about a new feature now that is the single batch container format. And this is a high perspective point of view of the Singularity image format. This Singularity image format seen in a computer is just a high level abstraction, is like a tar file. So in a single file, you're going to have the whole operating system, the whole descriptors, the whole environment that your application needs. What is new with the Singularity image format? You can have this, some parts of that file signed. And this, what gives this to the system admin? This gives a trusted computing. Because you're going to have cryptographically signed parts of that Singularity image format, and you can say to the host, just run the containers that are signed, and that you can create a whitelist to run these containers. So a container that is not allowed to run in your HPC or your infrastructure, it is not going to run. Or you can say that it can run, but it's going to generate a report saying an untrusted container is running under this and this process. So what is good about the Singularity image format? You can have a part signed and a part not signed to, let's say, store the output of your process, because this is something that is happening on the go. So the output can go in a different block than the part that is signed. The part that is signed can be the binary itself. So this is an abstract of what I've just said. Extreme mobility is controls compiling. So where we're trying to go into the next Singularity release is here. Users will be able to pack in a single container different architectures of the same binary. So instead of storing them in different folders of the same container, as I hear about it from different users, we are now giving the users the opportunity to do a cross-compiling, saving that in the zip file, and Singularity will handle that at runtime. So when the users create the container, we say, please create this container for this, and this architecture, and ship it to the infrastructure. And when running in the infrastructure, Singularity will tell at runtime, okay, this is this X architecture, I'm going to take this part of the container to run the process. And the extreme mobility is what I'm telling you. It's like moving a tar file, so it's really easy. Reproducibility. This is really important for academia, for HPC, for academics. So when you are shipping a container to a peer review, so let's say you just submitted a paper or a conference talk, and your peer review is requesting you how to reproduce those outputs that you are saying you have. So with your container, you just ship the container to a peer review, and he's going to be able to reproduce the same output that you have, because you are going to ship your environment, your file system, and your binary. So this is going to enhance the reproducibility for the peer review. So the difference here, you can see that Singularity will be a trusted container versus the other runtimes that are storing things in layers. Container mobility. Right now, we are being used by Microsoft Azure, Amazon, and Google Platform, and also Exit, Penguin, and Open Science Grid are running Singularity. So if you are developing in a Singularity container, it would be really easy to deploy your application in these resources or to move your container around these resources. Singularity is built especially to support HPC and EPC. EPC is enterprise performance computing that is quite similar to HPC, but not that performant. So when blocking some stuff from HPC to ensure the enterprise politics and stuff, you're losing the edge, but you're still having some performance. Is compatible with HPC and HPC architectures. Why we are saying this? The container runtime that enables GPU usage and different network boards right out of the box. So you don't have to do anything special to run a GPU or to run an InfiniBand or to run any specialized hardware that you have. Because like the container is sharing the same kernel that the host, you don't have to install any drivers. I know NVIDIA is doing a great work with GPU containers, but that's a forked Docker runtime instead of just sharing the same kernel host and being able to use the architecture of the host without any specialized setup. Unique security models. So Singularity right now gives the system admin the ability to, the same permissions that the user has in the host are the same permissions that the user will have inside the container. So depending on the system admin configuration and the permissions they give to the users, the processes that the user are running inside those containers are the same permissions that the user has outside the container. With the new releases of Singularity, we will be also giving to the system admin which system calls are those users running inside that container. So we are giving system call monitoring to the system admin, so the system admin will be able to tell the system calls being called from each container from each user. And this attached with the trusted container, so if a container is not signed, the system admin will be able to block the system calls depending on the user. So we are doing integration over isolation. This is integrated when I speak with the GPU part. So Singularity can use the GPU without any setup instead of Docker. That Docker also is using C groups. And if you want to do a use GPU inside Docker, you have to install the NVIDIA drivers inside the Docker container to be able to use the GPU drivers on the host. So we are going to in the path of integration, not isolation. So HPC, EPC. So this is what well, on my path, I always have my Jazz InfiniBand. You can leverage all this from inside a Singularity container without any special setup. So we have, there's a huge community doing a Slurm plugin, and it's pretty easy to use. So if you have a Slurm HPC infrastructure, you can run Singularity out of the box. You can use GPUs. You can use MPI from outside the container. So this is pretty awesome, hard to demo, but you can run MPI run Singularity. So MPI would be running a process inside Singularity, but you don't have to install MPI inside the container. The process is just going to read the environment inside that file system that Singularity gives, and then go and speak with the MPI install in the host. Well, the EPC part is untrusted users. So this is an example from last week. They found some Docker containers that were doing crypto mining. So users were leveraging the Docker usage in some enterprises to do Bitcoin mining. So this is why we say untrusted users, because inside the same company you can have users trying to do Bitcoin mining. And we also are giving resource management manager support. So that's pretty awesome. This is the Singularity use case for any HPC scheduler. So a Singularity container image can be seen as a compiled binary. You can ship it through any HPC scheduler. Because, well, again, I can demo it. When you build a container image, you can run it as a binary. So you don't have to call Singularity to run that image after building that image. So it's a compiled image, and you can package it via any HPC scheduler. This is why using Sylabs, using PBS, using SD Condor goes so easily after building a container image. And we don't use a container daemon, and we don't use a container program workflow. Singularity, after building a container, it can be just shipped through any HPC scheduler. Performance. There is also a lot of scientific work out there, papers, about how using Singularity can boost the performance of some applications. I quote, some applications can run better inside a container. So this is one example. Using Singularity from an NFS can be quite faster. I'm careful with these words. Running a Python process. So this is a comparison by running 1,000 concurrent times a small Python program. And running inside Singularity is faster than running in the same host without Singularity. Here, also another comparison. Using MPI from inside a container and in the same host without a container. So here you can see that the latency of the bandwidth was less by using the Singularity container than using the CentOS that was in the bare metal HPC versus. So why this is happening, this is why I always say some processes, when using Singularity, they go into memory and they start running from memory. When you haven't, then those processes in the bare metal, they have to go and read the process once and over again, and this is why this creates some latency. So this is why I said some processes can be boosted on performance when using Singularity. Well, twice. You can run this benchmark by running that GitHub link. You can also look for my GitHub account. I'm going to give it at the end. And I have a suite of container benchmark to test if in your infrastructure you can have a small performance boost by using containers. Some use cases, I'm happy that I have the first use case here. This talk was yesterday, so I don't have to say much about it, but Nextflow and Singularity are best friends. So if you like Nextflow, please try it with Singularity. Paulo. Open Science Read is also using Singularity. Last year they reported a day when they run 1 million containers in a day. So this is a graphic of the containers used on Open Science Read daily. So it's pretty awesome, the number of Singularity containers being used on Open Science. What Sylabs is bringing into Singularity? Well, we are giving Singularity Pro that is better than the open source version. So we are giving support to users that want support for Singularity. Professional services like training, like on-prem installing the Singularity, helping the system admin to install Singularity. And we're expanding the ecosystem. So like my job, bringing Singularity into OCI, Kubernetes, compatibility, Mesos compatibility, and I can show that here. Container library that is a professional container library. those users that already use Singularity, I encourage you to go and try our container library. Users that already know Singularity, they know that there is a Singularity hub, but that's an open source effort. This is the Sylabs product for a library, and this is my user. And I'm going to show you how this is better for reproducibility and for version control of your software stack. So this is a more Git-based model when you can have the same, when you're going to be pushing your container once and over again, that container is going to have a hash, and you're going to see the different hashes of the same container stored on that library. So this is pretty good for version controlling, because other container libraries, every time you push a container, it is removing the one that is up there and replacing it. We are storing every hash of that container, giving the users better version control library. And you can download the zip file with a graphical interface. Well, let's go by this. So Singularity Pro is coming from the open source part, but we are giving also security and major bug fixes to the Singularity Pro. So every time a security bug is found by using Singularity, we are going to report to the Singularity Pro users and then bringing that fix to the open source community, as the major open source project does. Like, first report to the pro users so they can make the fix before going public and telling what the security hole is. Singularity open source developers, we have a big community on the open source side. Here are some people that I know on the Slack, or at least have made a comment to Singularity. So it's a pretty big open source project. And Singularity users are more than our open source contributors. We have some Singularity users here. Nice to here. And these are some quotes of those users. But I short on time, so I'm giving you the links and time for questions.